Okay, hello, this is Dr. James, and today I'm going to talk about the TinySA Spectrum Analyzer. And it actually goes up to almost a gigahertz. It has two different bands, a low band, which goes from 0 to, 350 megahertz, and then I think the upper band goes from like 200 and some megahertz up to 960 megahertz. And it does all sorts of different measurements. You can do waterfall displays with it, max hold. It can measure third order intercept. It can store a trace for comparison. It can measure frequencies. You can change the resolution bandwidth. Pretty amazing for a scope that's less than $100. Portable, handheld. Runs on a lithium battery, I assume. Can generate signal outputs. You can I use that to pick up on my radios, so you can measure a modulated signal that it can put out. So you can do testing with that. So it can do input and output. It can be used as a signal generator. And pretty cool device, huh? And almost up to a gigahertz output on the signal generator and input. Okay, I'm going to do an unboxing and demonstrate some of the functionality of this, go through some of the functions, and it should be pretty cool, huh? Okay, it looks like it has finally arrived, and let's see how we can open this thing up. Gosh. Come on. I think it opens up this way. Let's see what's in here. Okay. Oh, look at this. It's a spectrum analyzer. Oh, this is so cool. Yeah. Now everything's coming down in price, huh? These things used to be super expensive. Now you can get one that's fairly decent for less than $100. Let's get this thing out of the bag, I guess. Huh. Let's make a little bit of room for this. Okay. Okay, so we have a little plastic bag around this guy, and let's take a look here. TinySA Spectrum Analyzer. Oh, and there it is. Oh, very cool, huh? Look at that. Let's take it out. So it looks like we have a high and a low side. Okay. That's probably so you can measure higher signals and not burn out the thing. I know about burning out instruments because I burned out a lot. Looks like there's... Oh, what kind of plug is that? It's not a standard one. Hopefully they sent me something. Some kind of roller thing here. Switch there. There's a couple ports. I assume these are SMA. We'll take a look here. Yeah, definitely SMA ports on that. Okay. Looks like we have some more SMA cables, short SMA cables, and a little antenna, so we can measure frequencies radiated. And I guess the other instrument had a little stylus like this. It's a little thing to point at the screen, I guess. I've been using my fingernails on the other one. It seemed to work, but probably should. This might be worth trying out. You can poke the screen. The screen's kind of tiny. I've got fat fingers. Anyway, looks like we got comes with a little SMA adapter, female to female, and hopefully this is. It almost looks like a. Oh, you know what this is? I bet. Oh, come on! Is this a rubber band? See if I can take this super tough rubber band off. Oh gosh. Okay, super tough rubber band there, and I think I have one of these for my 360 camera. I think it's a USB-C, micro USB-C. Okay, so that's cool. And looks like it comes with a little string that you can attach to the instrument someplace, probably. It's probably a little in the corner or something, somewhere you can hook this string cable to. I don't see a place for it, but it looks like it's got a guitar pick with it too. That's pretty interesting. Not sure what that's for. Okay, anyway, let me I think the first step will be is I'll get my USB cable plugged in and get this thing charging. So unplug something from the computer here. We'll take our cable and plug it into our computer, and then I guess here's our USB port up here. So see, USB-C is kind of cool because you can plug it in either way. And oh, it looks like there's a little red light that comes on here. I think it's black, so I can't see black on black. Okay, so a little red light that comes on to show it's charging. And I guess let me charge this guy for a little while, and then we will have some fun. Okay, should be interesting. Oh, okay, well this thing was charging. I was looking around to figure out where we gotta hook this little carrying wire onto, a carrying loop. And it looks like on the back of this guy, right up in the top corner, there's a little hole that goes through to this center part here. And I bet if I take this cable and kind of this little loop here, kind of pinch it. Okay, I guess if you grab it like that and pinch the loop really small and hold it just at the right orientation, you can shove it in there. Look at that. Yeah, see, I can get my little copper wire under there and loop it through. Look at that. Do you see that? Oh, I looped it through with the copper wire. Okay, now we're going to want to send this other end of the loop through that little loop. And that will keep it fastened on there. So you stick the big loop through the small loop. And I think we should be good to go. We'll have a guitar pick also, just in case we want to play guitar while we're using our Spectrum Analyzer, I guess. Okay, there we go. We got a loop on there. I'll just let it charge for a while now and we'll test her out. Should be interesting. Okay, so it looks like our charging light went out, so I took it off the charger, and let's peel off this plastic thing so we can see the screen. Let's see, there's some switches up here. Let's try turning her on. Okay, and it looks like we have power. I'm going to hook the antenna. We have this little antenna thing that came with it into the low input side, so we can hopefully measure some low frequencies. Okay. And let me bend this antenna. See, the antenna bends, and we'll see what we can find. Sniff around here. Look at that. Very cool. It's got a peak finder, a bunch of frequencies in the different megahertz range. I'm just wondering. Of course, maybe I should put it in the high end. I have my my Bofang radio here, and maybe we could measure some frequencies of that. See what this thing's transmitting. But let me switch this to the high input port, and then we'll try turning on our radio and see if we see a transmission from that. Should be interesting. Okay, so here we have our Bofang radio, and I put it on the high input. And see, when I hit the PTT key, the transmit key, looks like we're picking up a signal. And I believe this, there's a bunch of, probably for modulation down at the bottom also, but I believe that's, that first signal that comes up is 227 megahertz. Let's see it. It's right about there. Okay. So definitely we're picking up some kind of signal when we're transmitting from this guy. Very cool, huh? I bet you we can sniff out lots of signals with this. And have lots of interesting projects. Have some really high-speed signal generators that I want to measure that I have no other way of measuring them because my oscilloscope, well, actually, this one only goes up to almost a gig. Remember, my oscilloscope's about 100 megahertz. It was, let's take a look over here. It's a Rigol 1052 50 megahertz scope. And it says, what does it say? 50 megahertz analog bandwidth. But I did the special upgrade. Turns out that you can do a software upgrade to make it 100 megahertz, and people found out about that, and the Chinese vendors tried to change the software so you couldn't do that anymore. They basically build the same scope but disable part of the bandwidth so they can charge more for the other ones. You know, same scammy things typical corporations do. Anyway, but someone found a workaround, and I was able to do that. Well, the option was available. Not sure if you can still do that, but we'll see. If anyone finds out about that, just be sure to write me in the comments or something. Be interesting to know if you can still upgrade those scopes to 100 megahertz. But anyway, my point is that this thing goes up to almost a gigahertz. It's like 900 and some megahertz. So it extends my capability. It's a very cheap device, very portable, very cool, huh? Let's see what else we can do with this. Okay, so I was just looking at some of the options here. It turns out that this totally knob up here moves the cursor back and forth, and so you can find out what your frequencies are. You know how it's kind of like auto-finding the peaks? That's weird. Okay, there's our peak right there. Okay, so I was able to twiddle this cursor. Turn this down a little bit. It's hard for me to do both of these things at the same time, but twiddle this cursor over to that peak so we could determine what frequency that was. Again, this is knob up here. So we have a way of measuring what that frequency is. If I had three hands, I could definitely do that right now. Okay, there we go. We got it at the peak. And you can see that that is 277 point whatever megahertz. I'm sorry. Get that into focus. And so there we can measure our peak transmission signals by tootling with this knob up here. Okay. The low is low frequency. It has a band from about 0 frequency, close to 0, all the way up to 350 megahertz. And the high one is the high band, and it goes from about 248 to 960 megahertz, so almost a gigahertz. And I guess it was just picking up subharmonics or something when I was doing the Bofang radio before, because now when I transmit, there is a very strong signal here at 443 megahertz, which is what the Bofang says it's transmitting at. So those other must have been submodulations or something like that. We're definitely getting a very high power spike there. Okay. And okay, let's test our cell phone. Call my favorite store here, Walmart. See what happens. Oh, look at that. See? Look at that. What frequency is that? 778 megahertz. Right? Very cool, huh? Look at that. And we'll turn off the phone and the signal goes away. Very cool, huh? Of course, it looks like it transmits sometimes by itself. Okay, so another application for this guy. Definitely can measure in on the cell phone frequencies. Listen in. So let's take a look. See this button up here? I found out if you press it in, it gives you a menu. And this screen is touch sensitive, so you can change the start and stop frequency if you want over that span, reduce it or whatever, change the RWB, the video bandwidth, span, zero span, lots of options here. Okay, I guess you can store different presets. Level. I pushed the wrong button. Did I fat finger that? Okay, so you can change the scale and the attenuation. Let's try the attenuation. We can put either 0 dB or what is that, 22 to 40 dB. So I guess it just chooses, just put some attenuator in there, and it's different over the band. I don't know. Let's take that back out. Okay. What else we got here? And again, I'm pushing this button down here to get the menu. External amp. I'm going to have to look through some of these different options. Sweep settings. Okay. I guess you can click on the screen to get rid of the menu if you don't want it. Okay, very interesting, huh? Okay, so I guess I went back and I put the attenuation in to measure this guy. So let's see, go back to the main menu, went to level and attenuation, and I clicked on the 22 to 40 dB. Okay, and let me click out of that. So that brought all the noise down, but I think what was happening is, see, it was turning red when I was transmitting on this guy, and now it's not turning red anymore. Or maybe it still is. Maybe I got to get this further away. I'll get this way back here. Okay, so I think red means it's out of scale. It's off the scale. Okay, so that's way too high of a power level. I just turned it off. Okay. And so turn it on when it's close. It goes out of scale, right? So I don't want to damage it. So I'm going to try to keep it within a power range that it wants to be in. So anyway, there's a definite use for the attenuator. Okay. And this Bofeng did a separate video on that. Pretty nice radio. Definitely puts out the power. Okay. Okay, so originally it started in the low mode, which is the low frequency mode here. I switch it up to high mode, so this is how I did it. I push down on this roller button up to here, and I get a menu on the side. It has something called mode here. And so what that does is that we can either switch to low mode by clicking on this guy up here, like so, or you can return the high mode, because you can't get out of this. And I think these other modes are like, it says out. These are in up here. This is out. I believe these are like, you can turn the device into like an oscillator, a signal generator. Okay, so I'll just change it to low mode. Oops, I must have fat fingered it. We'll try mode again. Okay, I must have hit the high mode, back to high mode. Oh, come on. Mode. Low mode. Okay, there's the low mode. So its start frequency is 0 and upper frequency is 350. And so I can click on that guy again and go to mode. I'll put it back in the high mode since I have the antenna hooked up there. And there's high mode from 240 megahertz to 960 megahertz, almost a gigahertz. Very cool, huh? Okay, so I'm just trying to test out some different modes of this guy. And again, you can push down on this button at the top here. Push straight down on it, like that, to get the menu. Or, let me tap out of it, you can tap over here to get this menu. And what I'm doing is I'm going into mode here, at the bottom. And so you can return to low mode. Low mode is low frequency mode, not low amplitude, as I found out. Input, which is what we're doing, we're measuring a spectrum right now. And what I want to do is I want to change to low mode out. Okay, so I'm going to use my fingernail here and tap that guy. Oh, guess I tapped twice. Okay, so this is supposed to give you a frequency out, and I have hooked the low mode cable to BNC adapter to my Rigol O-scope over here, and it's set at 10 megahertz and minus 6 dBm. Okay, and according to my calculations, minus 6 dBm is oh, let's see. Oh, actually, I miscalculated, I think. Because 1 dBm is 1 milliwatt. So minus 3 dBm would be half a milliwatt times, or minus 3 is a half a milliwatt. You're right. Because it goes a factor of 2. 2 is 3. So minus 6 would be a quarter of a milliwatt. Okay, let's see what we get on the scope here, because we're not terminating this in 50 ohms. I don't have a 50 ohm terminator for my scope, but let's turn the output on, and here we go. We got getting a sine wave on the scope. Turn it back off. It's off, right? Oh, it's just persisting on the screen. There's no trigger. Okay, whatever. There we go. Oh, come on, stupid scope. Okay, so that was about 0.3 volts. I'm going to turn that back on. So it's 200 millivolts. and so it's about 1.5 divisions, so about 300 millivolts, or 0.3 volts. And I think I did a calculation on that, and that was in the milliwatt range. I thought it was 2 milliwatts, but that doesn't make sense. Let me redo the calcs, I guess. Because it's a 50 ohm cable, so you'd have 0.3 volts times 0.3 volts divided by 50 ohms, right? Because it's V squared over R. But this is not terminated properly. It's not a 50 ohm termination. It's a mega ohm termination, so it should give a higher voltage than that. Maybe a factor of 2, I don't know. Anyway, we're getting some signal out. Let's see. Let's see if we can change this level. I don't know. 6. Oh, I guess it doesn't give me an option for. That's weird. Well, let me fiddle with this. See if I can get a different output level. Well, let's change the frequency. How about that? Let's try 20 megahertz. We can't measure 220 megahertz. Okay, now we have twice the frequency. 20 megahertz on there. And our scope only has a bandwidth of about 50 megahertz. Although I did do the upgrade to 100. Let's go up to 100. How about that? 100 megahertz. Come on. Okay, let's hit that. Okay. Well, it looks like we're measuring a signal there. I think this low band goes up to 200 megahertz, so I don't know what will happen if I put that high of a signal into my scope. It looks like the scope will still measure it, but it is greatly decreased in amplitude. You can no longer depend on the amplitude to be reliable with a signal that high. Okay, but we are measuring something. And let me, just out of curiosity, get some cursors here. Just measure the frequency. Come on. Okay, and it does say 200 megahertz. So our scope is measuring a 200 megahertz signal coming out of this guy. Okay. I don't think it goes up to 300 megahertz. Does it? No, I guess it does. Looks like our signal's getting kind of low here. Yeah, it's getting toward the edge of the sampling rate. But, yeah, it's probably about 300 megahertz there. That would be 300 megahertz. Okay. Well, it looks like our oscillator is putting out power at these different frequencies. Okay, so we can use this as a high frequency oscillator. I don't think I have anything fast enough to measure the high frequency bandwidth, or output here, because that goes almost to a gig. And that's probably even going to go past the sampling rate of our scope, because our scope is only a gig a sample. And Nyquist's limit says you can only really measure frequencies, less than half of that. So we wouldn't even be able to digitally measure that, let alone analogically measure that. Okay. So it looks like our frequency generator is working, though. Very interesting, huh? Okay, so we have our spectrum analyzer here and our Baofeng radio, and I tuned it to a high frequency because I wanted to test the frequency output of this guy. So let's turn this from, so it's input low right now. Let's turn it to a different mode. So we have mode down here. We'll switch to out high. Okay. So I'm going to change the frequency. So we have the Baofeng set to 519 megahertz. So let me change the frequency also to 519 megahertz. Okay. So let me turn on the output So we have the output off right now. I turn it on, and see that? It lights up blue. It's receiving a signal, but you're not hearing anything because there's no modulation. So let's go to modulation, and I'll do narrow band. Okay, so now it's narrow band at 1 kilohertz, and let's turn that on. Look at that, we're receiving a 1 kilohertz tone on our Bofang radio. Very cool, huh? I wonder if we do wideband FM. Okay, it looks like it's receiving something, but it's not. Oops, what happened? Okay, so it's on. Let me turn it off. Wideband mode. Okay, so the radio's not picking that up. Wideband FM, but it'll pick up narrowband FM as a signal. And I think I can change the frequency. Let's change it to 2 kilohertz. Okay, back. Oh, look at that. So it looks like our modulation's working on our output of our spectrum analyzer. We're able to pick that up on our Bofang radio. Very cool, huh? Anyway, just trying to test out the different modes of this guy. This could be used a lot to test your radios and your ham radio setups or whatever. Very cool, huh? Okay, so let's look at some of the more of the functionality of this guy. Oops. Okay, so let's go back to the main menu. So what I'm doing is I'm going under the frequency menu here, and showed earlier we have start and stop frequency, or you can go center and span if you wanted to find the frequencies. I guess you can do zero span, and there's the resolution bandwidth. Okay, so let's click on that, and it's normally set to auto, but you can change this so that it has a more accurate spectrum. It takes longer sweeps, or less accurate. It takes faster sweeps. You can command it. I commanded it the 600, so that is the slowest bandwidth, or the fastest bandwidth, but the lowest resolution, because remember there's a Fourier transform relation between the two. Okay, there's 30 kilohertz, and so you can see it scanning at the bottom. Now let me go to the highest resolution, and we'll see what we can do there. Come on, RBI, we'll go to 3 kilohertz. So when we do that, it takes a very long time to scan. I don't know if you can see this little green line down here, but it is still doing a single scan. It's slowly creeping across the bottom, and when that green line gets all the way across, you'll get a high resolution scan of the frequency over this range. Now I narrowed the bandwidth so you could see that it's actually zooming in on this particular frequency, because right now it just looks like a single peak, but after you do the scan it will have more detail, since we're doing a high resolution scan with the RBI. Okay, so we're about halfway done now. See, the green line keeps on going across, and I was actually surprised. This spectrum analyzer has some pretty sophisticated and advanced measuring techniques for a device that's less than $100, touchscreen and all sorts of other stuff. Okay, we're almost there. See, the green line is right here now. It's going across the bottom. Okay, come on. And see that? Now our peaks have much more detail. Okay, looks like it's going to start another sweep. Anyway, so you can change the resolution bandwidth so you can get signals out of noise or more details in your signal. Very interesting, huh? See this, The peak looks like looks like it has a side peak there or something that you wouldn't be able to see if you had the faster sweep or the lower resolution. You know, higher number there actually means lower resolution because it's sweeping faster due to the Fourier transform relation. Anyway, let's get out of this. I'll set it back to auto again. So I'll do that again. RVI, and I set it back to auto at the top. So it's auto scan. Okay. Very cool, huh? Let's look at some of the other functions of this guy. Okay, so I have this set on with the antenna coming into the low range, input at low range. That's low frequency range. And let's look at some of, let's see. Okay, I think this was level. I was looking at level. And I noticed they had an attenuation, so you can change the reference scale level, scales per division, and here's attenuation. Okay, so you can actually set on, so if you look over here, it has a reading for how much attenuation is in there. Right now it's got 0 dB. You could set it on auto. When you do auto, it looks like, come on. Okay, so it looks like it goes to, well, it's 0 dB right now. Okay, so auto, set it to 0 dB. But, it probably depends on what your signal is. We can change the attenuation. We'll put it on manual, and we'll say 10x. Okay. Now if we look at the attenuation, it says 10 dB. Pretty cool, huh? See the attenuation right there? 10 dB. And let's try this again. Manual. We'll say 100x. Oh, look at that. I don't think 100x is 52 dB, but maybe it's putting it in as dB. So it looks like maybe our max attenuation is 52 dB. See right there, attenuation. So you can put attenuation in here to protect your device from high power signals, I guess, in case you think that they might be getting a high power signal. You don't want it to get damaged. You want to measure a high power signal. Okay. And, you know, high power is relative. I mean, this is measuring like probably nanowatts or something. Okay, so anyway, there's the attenuation function. Very interesting, huh? Okay, so it looks like it has some other things. You can change the units here. dBm, dBi, or dBV, dB microvolts, volts, watts. Okay. External amplifier. What is that? I guess maybe you can calibrate if you have an external amplifier on there. Take that out. Okay, trigger. Okay, so right now it's set on auto, edge up, but it looks like you can do single trigger. You can do normal, so it's similar to a scope. Edge down, trigger level. Well, let's get out of that. I guess you can set the trigger level as well. Very cool, huh? And let's get back out of this. I guess I didn't do scale. So you can change the scale. It's got nano, micro, milli. Again, the back arrow gets you out without having to enter something. Okay. Let's get back out of this. So that was the level option there. Okay, so let's go through some of these other options. Again, click on the display, the screen to get these different options. I think we'll try display next. try clicking on display. And I was looking at some of these options. They have a calc here where you can do different things like max hold, maybe. I use that sometimes, where it will show you the max that you got if you got some kind of pulse signal coming through, and then it looks like it has the trace down below, the varying trace, and so it's holding at the max. Or let's see, I guess we could do 16 average over. So now it's just kind of averaging the signal, it's not holding it. Okay. Sweep settings. I thought this was neat. It had waterfall setting where it will kind of show you a scrolling time-dependent frequency map. I guess it'd be time in this direction, the vertical direction, versus frequency there. And so you can see how our signals are evolving over time. And I think if I hit the waterfall thing again, it gives you even more waterfall. It compresses the screen even more, so you can see more of the pretty little pattern that it's going to make. The frequency space. Okay. Very cool, huh? Of course, no frequencies are moving here, so it's going to look pretty constant. Okay, it's looking like pretty much straight bars scrolling down. Let's turn this stuff off. Let's see, I have to tap over here, I guess, to get our... Okay, we'll turn waterfall off. And let me turn the I'm going to calc XDK. I guess we can see what that is. I don't know what that is. Anyway, different ways of representing our signal. Let's turn it off. Maybe I'll try out the stylus. We'll see how the stylus works on this guy. If I can find the stylus. So we got a bunch of junk with this network analyzer. And it comes with a fancy little pen here. Yeah, let's take a look at this better. Okay, here's our pen. So maybe if you don't want to fat finger something, see if we can do this. Yep. Okay. Okay, there we go. So here we got our fancy little pen, and let's try storage. It says we can store a trace. I guess we could try that. See what happens. Okay, so we got a trace stored, subtract stored, cleared store. What happens if we subtract the stored trace? Oh, look at that. Gives us a nice signal, so we can subtract that. So you can compare if you got a new signal. Okay, whatever. I'm going to turn that back off. And let's get out of here. Normalize waterfall sweep settings. Just see what that is. Normal, precise, fast. Let's try fast sweep. Okay, so I guess we can make it sweep faster. Let's try to put it back on to normal. Let's try precise. What's precise? It's going to be probably very slow. See, you can see it sweeping very slow there. Okay. And sweep time, fast sweep setup, sweep number of points. Okay, so it looks like the max number of points is 290. Sweep time, I don't know what it is. Oh, okay, it tells you what the sweep time is, what you can set it to. Okay, fast sweep setup, again, you can change the duration of the sweep, looks like. And let's get out of here. So we can pause the sweep. Oh, pausing the sweep. Okay, so that's like stopping the trigger. Sweep settings, I think we just did that, right? Yeah, let's get out of here. Let's look at a few more settings. Let's see, I think we looked at frequency already. Start, stop, span. Level. Okay, oh, that's not what I wanted. Gave me the wrong thing. That's not level. Level should be scale per division, reference level, external amplifier, trigger. Okay. Display marker. Modify markers. I guess we can select what marker we're on. We can do a search for peaks, I guess, max and min on the markers, have them search automatically. Okay. Marker ops, I guess we can set a range for those two. Measure. Okay, it looks like I'm going to have to look at some of these other things. It's got harmonic, Q, OIP3, I'm not sure what that is. Phase noise, very interesting. Signal to noise ratio, minus 3 dB width. Oh, that's interesting. We can measure the 3 dB width of our signal just by... Okay, so it says it's 2 megahertz, so it measures that automatically at the peak signal. 2.4 megahertz. Very cool, huh? Let's see. And there's more options. AM, FM, THD. Center frequency. Okay, so I'm not sure what some of these things are. Looks like I'm in AM mode though, probably. Okay, I'm going to have to do some research on this. Harmonic frequency, the fundamental. Okay, wow. So it looks like it does quite a bit of different things. Let's turn this off. Measure config. Okay, we can configure the touch screen, I guess. Do a self-test, level calculation, or calibration probably. Here's the version of the device. TinySA version 0.3. Okay. Mixer device. Okay. LO output. Hold sweep. Noise level. Automatic gain control. Low noise amplifier. Correct frequency. Ham bands. Grid lines. I don't know what a lot of this stuff does. Modulation correction. Okay, very interesting, huh? So it has a lot of functionality. That sample repeat. Okay, let's get out of this. Okay, I think I remember this before. If you click on that, that's like to upgrade the software, so I don't want to do that. And that was in what, configuration? Okay, and of course we went into the mode. That's where you can switch between either input or output, use this as an oscillator, or measure signals coming in either in the high band, high frequency band, or the low frequency band. Okay. Now let's just return to that, I guess. Okay, very cool. Lots of functionality with this really inexpensive signal analyzer. Very cool. Okay, so it looks like OIP is third order intercept, which is a figure of merit of in communications. You know, how good is if you have intermods, if you have two frequencies, I believe, right? How much do they create harmonic distortions in the third order? Okay, and so this measures the third order intercept point, which if you extrapolate out these different measurements, they'll cross at a certain point, and that will be the third order point. And so I guess this handy dandy little device is capable of doing that. Harmonic, phase noise, very cool, huh? So this would definitely be a handy device for a lot of ham radio stuff, I'm sure. Okay. So I'm not going to set up a third order intercept measurement. I'd have to have two frequencies and other things, and maybe another video, we'll see if I get time to do that. But just wanted to do a quick test on this guy and see what the functionality is, and it looks like it's pretty cool, huh? Okay, so just as a quick test, I hooked up the USB-C, micro USB-C or whatever, to the computer, because I did store a trace in here, and I just wanted to see if the computer can download the trace in an easy way. And I did this with my other network analyzer program. It looks like it doesn't come up with something. A lot of times, like I think the network analyzer, in the other video that I did, I didn't talk about it, but I think there's probably some kind of proprietary software that you can download to pull those traces across. I'm not sure if it's the same with here. I've tried to do that before with my nanoscope, and I really didn't like installing whatever questionable software it was, and you know, some kind of special software you have to give it permissions to get on your computer. I don't like that. You know, if it doesn't look like anyway that this one you can pull that trace across in a simple way. If you can, you probably have to use their special software, and God only knows what it's installing on your computer. So I never did that with my other things, my other miniscopes and my nanoscopes and stuff. But anyway, just a quick test to see if you can get the traces off, and I'm not seeing an easy way to do that. So, moving on. Anyway, this is Dr. Janes, and thanks for watching.